quick information on optimization before we continue on Monday, I guess. Okay, optimization. This is technically our final lesson of derivatives here. But notice it says it's one of the most common applications in calculus. We often hear terms like the least time to get something done, or the greatest profit, the shortest distance, the maximum volume, the minimum waste. Okay? In order to optimize problems of this sort, we first need to find the quantity that needs to be minimized or maximized. All of those, if you noticed, they're asking about a min or a max. If we talk about the least time, the greatest profit, the shortest distance, they're all asking about a min or a max. And min and max is tied to derivatives, okay? Students often find this to be a challenging lesson to master due to the difficulty presented with finding the quantity to optimize. The constraints, I feel like, are usually a problem. And then writing the equation. So reading the problem is key. We need to read, okay? I know, big thing. Kind of like when we did related rates. I'm going to want us to read it and break it down, okay? I must have said Hannah's favorite words there. Identify the quantity to be optimized and the constraint. If a quantity is stated to be a fixed value, this will be your constraint, which must be true regardless of your situation. Or of your solution, sorry. So let's look at this first one. Okay, a little bit more basic. And I'm not going to say there's not ways to do some of the, like something like this. Do you have to use calculus to do this? Not necessarily on a problem like this one. But when you get to more difficult problems, they don't lend themselves to just easy figures. So it's the process we're trying to figure out here. So find two positive numbers such that the sum of the first and twice the second is 64, and whose product is a maximum. Huh?
So this is why
Okay. Oh, because you read that.
I never know how to do them.
Okay.
Just not that good at it.
So find two positive numbers. That right there is what we're being asked to find, right? We're being asked to find two positive numbers. I'm going to make these my variables. So I'm going to say let x be, I'm just going to say the first number. And then if that's the case, I'm going to let y be the second number. Okay, so that's what we're being asked to find. I need an equation.
X plus 2y equals 64. Yep.
Okay, hold the phone.
Notice I didn't say or write anything yet.
No, thank you.
Okay. Guys, it's reading. Translate it. This is the easy. It's here. I promise. You just have to read it. Such that the sum, what's sum mean? Addition of the first, what's the first? X. Twice the second.
2y.
What's is mean in math?
Equals 64.
There you go.
I got that.
Okay.
You cannot shout out things.
So x plus 2y equals 64. Now, with that in mind, if we're going to talk derivatives, do we really want it in that form to talk derivatives? No, not really. So I'm going to have a traditional problem where it's y in terms of x. I'm going to suggest we solve for y. So if we solve for y, 2y equals 64 minus x, divide by 2, and I left mine as just one fraction. 64 minus x divided by 2 is how I left mine. Not saying you couldn't make that, 32 minus x over 2. That's equally right. Okay? Now, so we have our equation y, and what is it we're trying to find? Or what is the other piece of information? Product is a maximum. What do we mean product?
Multiplication.
So what is a maximum? Well, no, but just in general, how do we express product? You said it's multiplication, but the idea that the product of x and y, so x times y, I'm just writing this down as kind of a side note to myself, needs to be a maximum.
Maximum what? Bigger, just bigger than 64.
A maximum, like a max as opposed to a min. Like, we're trying to find the two numbers that give us the, like, if there's multiple numbers that give me this product, we're trying to find the maximum. Or
Biggest one.
The greatest value.
the, how do I want to say this?
The highest.
If there are more than two numbers that can meet this situation or something, they're going to maximize my product. Okay. Now, in all honesty, this is a situation when there's not necessarily multiple answers. But when there are, we have to consider that. Okay. So we have this y equals equation, yes? And we're trying to, we want this product to be a maximum. When we talk maximums and minimums, we're usually finding the derivative, right? Well, right here, x times y. If we want, I don't want to go implicit though. What do we know about this?
Well, y equals 64.
Didn't we just take that amount and solve it? So here's what I'm trying to, and I have it written in my notes as f of x equals the function I'm writing. So x times y. X, I'm going to leave as x. What can I use for y? 64 minus x over 2. That's the equation that we are going to try and optimize, that we are trying to find the max of. That is an option. I don't know, which would it be easier to do product rule, or would it be easier to write this equation in a different form? In my brain, I see this as I would rather go ahead and multiply this
Yeah.
and then take my derivative. Now, could you take the derivative right here and do a product rule? Yes. Will we meet in the end somehow or another? Yes. Fair enough? So if I go ahead and multiply this, if I multiply the 64 or the x in, we're going to have what? 64x minus x squared over 2. However, I probably should have done this differently to begin with now that I think about it, but if we have that big fraction, could we split that in 2? And again, that's going to be easier to find the derivative of, yes? 64x divided by 2 is 32x minus x squared divided by 2, or how I'm going to write it is, well, you want x squared over 2, or you want
X squared.
1/2 x squared?
1/2 x squared.
Because this is a 1x squared, right? So we can write this as 1/2 x squared. If you want x squared over 2, that's fine. That's probably the more official way to do it, but I'm not about being more official. I'm about, do I have everyone with me? So, okay, now we're going to derivative. F prime of x is?
32
minus x.
That was too easy. See, we did all the hard work to begin with, right? So we made it easier there. If we're trying to find a maximum, what do? Set equal to 0. And
X equals 32.
add x over, you have x equals 32. Okay. What was the question asking?
What?
Two positive numbers. The sum of the first and twice the second is 64.
32 and
So can we just plug in the x into the x original equation? 64.
Yeah. So in other words, when it said find two positive numbers, my two positive numbers were x and y. We just found x. I now also need to find y. And since we're only given one option, we know that this has to be it. So we have x equals 32 and
Y equals 64.
y equals 64 minus 32 over 2. 32 over 2, which is 16. So x equals 32, y equals 16. Okay. Now, given a situation, if we'd come out with multiple x's, we'd have to do some testing and figure out which one is the maximum to use. It often happens though where you end up just finding one, so that ends up being the one that works. I guess I just have written in my notes, numbers are 32 and 16. What?
I said 20 and 22 still works though, but it's just not a maximum.
Is
20 is the first number though. 22 is the second number.
Sure.
And I assume, you've got me curious now.
Because
32 times 16 gives me a bigger product.
Yeah,
That's the key. Okay?
I did it in my head first.
And that's yeah. I get it. And I wasn't one, honestly, I was just doing this one calc this way. I can't say that I was 100% sure if there was more than one option or not that would work. So, interesting to know that there is. Okay, tomorrow, Monday. We'll finish these notes. And go from there. Okay?